Hello. In this section, we will introduce you how to set up the cloud service with MQTT in iRTU and EdgeLink. This module introduces how to use configure EdgeLink project to support MQTT uploading to cloud, for example, the WebAccess, Azure, and WISE-PaaS. The word publish subscribe is the term to describe the communication model in MQTT. There are four important elements in MQTT as the below diagram. You can see the message flow are all related to publisher, subscriber, topic, and broker. So there are four elements important in MQTT structure. A publisher will publish data to the topic on the broker, and if there is a subscriber subscribed on the same topic, broker will help to publish the data to this subscriber. A publisher can publish data to more than one topic. Likewise, a subscriber can subscribe more than one topic. That's why MQTT is so popular, since user can subscribe every topic he would like to monitor and receive those data with broker's help. Simply put, all devices need a broker for processing the message. Those devices are not just communicate to each other directly. So here is the example topology. EdgeLink's iRTU client connect with WebAccess MQTT Broker. We illustrate like this. EdgeLink MQTT client connect with this WebAccess MQTT Broker, and WebAccess has another node, and it will use as MQTT client to subscribe from the MQTT Broker. Okay, and in this example, the WebAccess node and WebAccess broker may be in the same machine. It is also fine if WebAccess node and broker are different machines. So this slide summarizes some MQTT features. It's a lightweight protocol for IoT messaging. The communication model is publish and subscribe model, as this picture shows. It can realize one-to-many messaging. The header of MQTT is really small, which is suitable for low network bandwidth applications. MQTT provides quality of services data delivery. MQTT uses hierarchical topic structure and wildcard subscriptions, which is convenient for user to do management. The last will message can let user know the client's status if it is disconnected. For uploading the MQTT to the different broker, we just list as below. We will introduce in this order: WebAccess, Azure, and WISE-PaaS. So there are different MQTT brokers we supported in this period of EdgeLink Studio. We support the broker Simple MQTT and WebAccess MQTT, Azure IoT Hub, Pro Smart Cloud, and WISE-PaaS. The difference between using each broker is the packet payload, and it makes whether each cloud engine can parse the payload or not. So we support all these payloads, and user can choose as what their requirement. And iRTU EdgeLink supports standard MQTT 3.1.1 and 3.1 version. Okay, our first example is connecting with WebAccess. So we choose the WebAccess in the categories of cloud service. In EdgeLink Cloud setting, enable the WebAccess Cloud. Leave it disabled as default if you don't use Socket 5 proxy server. If user wants to enable it, click the Enable section inbox and check the Edit button to set the SOC server information in the pop-up box, including the server IP address, port number, username, and password information. And the host, please fill in the broker's IP or domain name. For the port, set the port number the same as WebAccess broker's port. Choose whether to use enable SSL. Connection does not enable SSL security connection by default. If click the Enable section box to enable SSL, user can choose 3 authentication methods: anonymous connection, or server authentication, or mutual authentication. User can leave it unchecked as default if you don't need authentication. And user need to set the MQTT version. Either can be 3.1.1 or 3.1. Okay, next is fill in one client ID following the spec of the broker. Randomly generated name is fine if the broker does not define. Okay, and fill in the user's name and password following broker's requirement. The keep alive and timeout, user can leave in as default. And the periodic publish, the client can choose to upload the text information regularly. In this example, it is 3 seconds it will publish to the cloud. And the client also can choose to upload the information when the text change. If it checks the differential publish, after checking it, user need to set every detection cycle, for example 1 second to check, and if the value change, it will upload. Please note that the differential publish and periodical publish can be defined at the same time. And for more parameter configuration for WebAccess MQTT, there is the group ID. The group ID needs to be defined as the project name of WebAccess and the node name in a button line combination. So like this, my project button line my SCADA node. In this name, it is the group ID. For the device ID, fill in the name, which is the topic that WebAccess MQTT client would subscribe as device ID. And heartbeat period, that means the client will send heartbeat message to WebAccess, and the interval is meaningless if they set more than WebAccess client heartbeat beat period. Okay, another 2 parameter is publish control. If it is enabled, WebAccess broker can control EdgeLink to publish or not. And for timestamp, there are 2 formats to set up, like UTC or local time. EdgeLink MQTT WebAccess configuration. User may refer to this document. In this document, you can see how to configure the WebAccess and get the broker setup, and also how to subscribe the topic. And here is the result. User may use the third-party MQTT client software to subscribe the WebAccess MQTT Broker. The published result of ADAM 3600 can be shown like this. You can see the published like the topic and value of each tag. We briefly introduce uploading to Azure as below. The setup of Azure MQTT Azure is almost the same as previous introduced in WebAccess. So double click for the Azure and then enable the cloud. And choose the address format as connection string. Paste the connection string you copied from Azure device. For demonstration, check periodic 2 seconds and add the tag you want to monitor. Click apply for saving the setting. And it is quite easy for Azure uploading, but user may need to check with the Azure IoT Hub in Microsoft Azure. So in this document, we will detailedly introduce you where to get the connection string. And the Azure, there is a special tool to monitor the broker. So it is called as Device Explorer and provided as open source. If the device has restarted successfully after you download the project, you can see the uploading message here. You can also select the device name and the board I/O like this value. The third one we will introduce is for the WISE-PaaS detailed configuration. It is almost the same as previous cloud. So in Azure cloud setting, enable WISE-PaaS cloud and enable it. If you want to use the circuit process, just choose it. And you need to choose the username and the password, and also there is a default host. User may no need to change it. And enable the periodic publish for publishing. For example, we set here as 2 seconds. And more details are like this. User can set differential publish, and the important is here the number 9 credential URL. User need to copy it from your WISE-PaaS management portal. And also the IoT key is get from each user's management portal. So this demo we use like this portal, but user may need to change for their own IoT key and credential URL. For the SCADA ID, following WISE-PaaS instruction to fill in SCADA ID, and device ID also need to follow in WISE-PaaS management portal to fill in it. Now, user need to define their own device ID for each different device. So if there is 2 devices using almost the same project, user need to check their device ID is different. User can also change the timestamp format. For the WISE-PaaS configuration, please refer to this document. It will introduce you how to use the WISE-PaaS portal and how to draw the Grafana photograph. So here is the hands-on. The application scenario may be illustrated as the image. We use as the 3 steps. Step 1 is to set up the broker. Either use Hive MQ or Mosquito broker. And second is set up the iRTU device for publishing. And third is monitor with other online clients. So, hands-on step 1, user may need to download the Hive MQ Broker. Okay. The free trial version has some limitation, but it's okay for this demo. After you fill in your information, you can get the download link, such as this in here, download. Following the README and click on the bin run.bat. The broker on your PC would start to listen connection. The default setting is no username, no password, and port is 1883. So this is okay enough for us to connect it. The step 2 is to build your own connection in your ADEN 3600 or iRTU device. Set up the host, that is the IP of your broker, and or you can fill in the domain name and the port 1883. And there is no username and password, so you just generate a user created tag for this. Step 3, you need to monitor on MQTT client. There is one MQTT client tool called as Paho. You can download from our official website, and user may also use other third-party MQTT client software listed at below. The result will show like this. Fill in the server URL and Hive MQ Broker. Click connect if there is no error. The status will show connected, and user can add a new subscription with all topic, wired card, and then click subscribe. User can monitor the status or results here. Once you got the results, that means you can upload to the broker, and you can also subscribe and monitor the tag. Thank you for listening.